Okay guys, I'm just gonna do a quick tutorial here, right? If you have an oblique plane, I'll just draw in an oblique plane here. So the 3D of that, vertical trace is going like that. The horizontal trace is going like this. So that is our plane there in 3D. Now, you might be asked, what is the real angle that this plane makes with the ground? It's like, you know, if you had a set square here, and you might ask, what's the real angle that the set square makes with the ground? Well, there's a way of doing it that involves putting in a semicone. So it's going to look like a semicircle in plan, and this cone is just made to fit. I'm going to try and color this in. In blue. So that's our semicone. Okay, so it's only a half a cone. And it's a tangent there to the horizontal trace. So, so I'm going, sorry guys, dying with a cough. So I'm going to just anywhere at all, doesn't matter where you do it. I'm going to just go at 90 degrees to the horizontal trace. So that's going to be the vertex, the top of my cone. Now, does not matter where you put this in. So I'm going to draw in my semicone. Now, that's the top view. Now, what is a bit confusing here now is that this is the front view of that cone. And I know it's confusing there now, but that is the front view and the top view, but they're connected onto each other. And this here, that angle there, is the true angle between the oblique plane and the ground. Now there's another way you could think about this if you wanted, and at the risk of confusing people, I think I'm going to try putting it in as well, is it would be a bit like if you had in the 3D here a set square, like a 60-degree set square, and if you said that thing in red there is the set square, and the front corner here, the front angle here is going to be the true angle, and it's like you rotate that around until you're looking straight in at it, but you don't move the height, and that there in red would be the front view of the set square and the true angle here. So you can think about it as a cone, or you can think of it as kind of a triangle, but either way it works. That is the true angle between the oblique plane and the ground. Now I suppose there, just before I'm going to do there the same question there using the auxiliary method, or by taking auxiliary view. I probably should have stuck in the key concepts here, I suppose, as well. So the key concepts here is that you put in a semicone in plan, then draw in elevation, and the vertex of the cone must be on the vertical trace. So once you make the cone in the elevation with the vertex on the trace there, so just straight up from the center, and this gives the true angle. In elevation. Okay, so I'm going to move on there. So I should have stuck that in at the end of the last video. Now there's another way you can do these questions. I'll just set that up there. So instead of using a cone, it would be, I'll just go back up to the other one again for a second, to the 3D here. So instead of using a cone and you're the person standing looking in here, if you made your way on over here and laid down on the ground there, panned out, and looked up along the horizontal trace. So if you saw the oblique plane as an edge view, you're going to see the true angle. So that's what we're going to do down here in this other question here. So and it's really easy, because you just want to look along the horizontal trace. So here's my angle for the horizontal trace. I want to look along that. I want to put an XY line anywhere up here that's 90 degrees. So I'm just lining it up here at the side. So my XY line has to be perpendicular to that. Okay, so that's perpendicular here. So this is, and we know now that the oblique plane is going to start here, but we need a height for it. So what you need to do there is pick any point X here on the vertical trace. Bring that down to plane. And we're going to project that up now at the same angle. Whoa, from plane. So that's X in plane. And I'm going to take the height there now. So we know X is, you're projecting from plane. So you're taking the heights from the elevation. So this here now is the edge view of the oblique plane. And that there is the edge view of the ground of the horizontal plane. And this here is the dihedral angle, or the real angle between the oblique plane and the ground. So the important thing is that this is done by auxiliary method, and that is done using a cone. So that's the kind of thing you could see in the short questions there coming up, where you would be just asked, there are the traces, find the true angle between the oblique plane and the horizontal plane. So either one of them would do. Now this on the right hand side, then it's less common to be asked the true angle between the oblique plane and the vertical plane, but it's the exact same idea. So I'm going to draw in here my vertical trace, just guessing it from that, my horizontal trace. So here, vertical trace, horizontal trace. So that's where they're going through the ground and going through the vertical plane. Now, it's the same thing again, using a cone method, except the last time we put the cone down here, whereas this time we're going to put a tangent cone in elevation like this, and because that's 3D now, there would be the center of the cone, and that's the angle for this. So that would be my 3D cone. I'll just try and color this in there now to make it a little bit more realistic. So that's my cone. All the lines going to the apex. Okay, so that's what the 3D view looks like. And again there, like the true angle is going to be, this cone is just made to fit perfectly. So to do that above here, I will just get the angle of the trace and any random place at all. I'm going to just come down here and put in a perpendicular. So that's going to give me the vertex of the cone, so there's a point of my cone. Set your compass to this. So there is my semicircle. There's my cone in elevation. Bring down the vertex. The vertex has to be on the horizontal trace. And this would be the plane of it. Let's do it with the pencil. That would be the plane of that half a cone. And this here is the true angle. So that there is the true angle done using the cone method. Now, what people find confusing there, and this, I'll just put it in again, is like, let's say our lines of the radiating lines there. Oh, I can't, here we go. Just sharpen the old pencil there. But in elevation, the lines radiating out there would be like this. So here's our semicone in elevation. Now this might just help you to picture it. So we're looking up along the point of the cone there, and in plane they're like this. So in plane, in the top view, that semicircle is contained in the vertical plane. So yeah, that's the problem with that. You know, some people struggle to understand that. And if I was to do that like the last time there, I was saying you could think about it as putting in a triangle. So that would be the triangle, and then you swing the triangle down onto the ground, and that triangle would be here. That would be another way to think about it. If I drew that triangle then over here, the line along the ground is going to look like that. This one goes up to the point of contact and back out to the point, so it's kind of hard to see it there now. It's a very almost an edge view. Maybe I'll colour it in a bit. And then you rotate it down onto the ground, and when it's knocked down onto the ground, then your triangle is down here. So, and finally, I would always prefer cones for this, but they just asked there to do the same thing again there, to find the true angle between the vertical plane using the auxiliary method. So the true angle to the vertical plane, I gotta look along the vertical trace. So it's kind of similar to the last time here. Gonna be looking along the vertical trace, putting in an XY line here. Keep it fairly close. We're going to pick a random point X here that's on the ground. Bring that up. Project that out. So I'm projecting from the elevation. I'm taking my distances from plan. So that's the location of X. And this here is the true angle. Okay, so that there is an edge view of the vertical plane, and that's the oblique plane, and that's the true angle. But the most likely way that you're going to see that is, I would say it's, as a short question, it would be in this format. So yeah, that's page 104.